Welcome to the first talk of our 2021 series on talks related to augmented and virtual reality. When we hear from luminaries in the field, their opinions, their perspectives, and ideas. I'm super excited to welcome David Smith today as our guest. Welcome, David. Thank you so much for joining us today. David is the CEO and founder of Croquet Corporation. We're also collaborating with Croquet in this capstone that we're running in parallel. The company is developing Croquet Greenlight, which is an augmented reality collaborative operating system. David has over 30 years of experience in the field. He's a computer scientist and entrepreneur with specialty in system design and advanced user interfaces. He was the Chief Innovation Officer in Lockheed Martin, as well as Senior Fellow, where he was focused on next generation human-centric computing and collaboration platforms. Before joining Lockheed Martin, David was the Chief Architect in Croquet Project. I guess it's a predecessor to the current Croquet, right?
Yep.
Was an open source virtual world collaboration platform where he worked with Alan Kay, the Turing Award winner, and David Reed, who created UDP and TCP/IP. I was super excited to see that David, in 1987, David created the Colony, first-person shooter game. In 1987, we were just chatting with David. Doom, if you heard, many of our audience is super young, but if you heard of Doom, then that was like 5 years later, right, David? We were just chatting about that. This game was developed for the Apple Macintosh and won the Best Adventure Game of the Year award from Macworld magazine. David also founded several other companies, as Virtuos in 1990, the first real-time 3D design application for personal computers. Also won awards, as well as Red Storm Entertainment with author Tom Clancy. It's so cool. And co-created the Rainbow Six game franchise. Welcome, David. Super excited to hear everything you have to say. And yay, take it away.
Oh, thank you. So yeah, I really appreciate the opportunity to talk to you about some of my passions here and some of the challenges I think we're going to face. Yeah, I've been doing interactive 3D and collaboration my entire life, pretty much. I mean, I'm old enough now to say I've been doing it longer than I haven't. And this is a particularly important thing to me, and I hope it is to you as well, this idea of what I call an augmented conversation. And I use that term extensions of you in a very specific way, and I'll touch on all of this. One of the lessons you should take away is study the past if you would divine the future. And I think this presentation will kind of illustrate why that's so important, because so many of us think that we're inventing the future today. It's actually, a lot of it's already been invented. We just haven't implemented it. This is Confucius that said this. This is one of my favorite quotes in the world. I'll read it. During the mechanical ages, we had extended our bodies in space. Today, after more than a century of electric technology, we've extended our central nervous system itself in a global embrace, abolishing both space and time as far as our planet is concerned. You read that, you think, oh man, somebody wrote that like a couple of years ago. And indeed, it was Marshall McLuhan in a book he wrote, Understanding Media, in 1964. Note the subtitle of that, The Extensions of Man. This is a really powerful concept, this idea of a global central nervous system that we're all part of. And of course, when you think about the internet, you don't necessarily think in those terms, but you should. Example, someone tweets and a few milliseconds later, millions of brains are impacted. So our consciousness is extended. My consciousness is extended into your world, yours is into mine, but it's not always a good thing. That's one of the the big challenges. But to think about this global consciousness that's evolving is a powerful, powerful thing. Not always good, but that's one of the things I want to address and talk about. You know, what's actually needed. Doug Engelbart is a personal hero of mine, and I'm going to talk a little bit about what he did and why it was important. But this is at the heart of it, where he says the key thing about all the world's big problems is they have to be dealt with collectively. If we don't get collectively smarter, we're doomed. That's true. We have a big challenge ahead of us, and unfortunately, we tend to be getting collectively stupider, and it is a danger, because if we don't get smart, we are going to have challenges. In 1962, 2 years before the book that McLuhan wrote, Doug wrote this. It's almost a book. It's about 120 pages long. It was done for ARPA before DARPA existed. And this is the same group, by the way, who said, hey, we must have an internet, or at the time, a galactic net. This concept he wrote, Augmenting Human Intellect, a Conceptual Approach. If you read this paper, and I suggest you all do, it's even though it's 62, what you'll find there is, in a sense, science fiction today, even though much of what he described, he built. The sad thing was, even though he had it built and had it working, we kind of lost it. And this is one of the things that we set out to address or try to fix. So Doug understood the computer as a medium to extend humans' abilities to think and collaborate. But more importantly, it was this idea that there was a symbiotic relationship between the computer and the human, and more importantly, between the human and the computer and the human. In other words, the computer became this a way of mediating relationships and idea spaces between humans themselves. And that's a key idea. When you think about what you're building, when you do a computer program, what you're really doing is creating an engagement, a communication between you and the computer. But if you can make that collaborative, then you're amplifying the value of that system and the power of that system, because you're now using that computer as a medium. And go back to McLuhan's name of his book, Understanding Media. Was, I think, Alan's big insight, Alan Kay's insight, I'll talk about him in a bit, was that the computer is a medium. And Doug implicitly understood this and really made it happen. In 1968, he did a demo to one of the big computer conferences at the time, and it fundamentally changed the world. Now, Doug was, among other things, he invented the mouse. That's what he's most known for. But the reality is, the mouse is kind of like, well, I created a steering wheel, but I also created this car. You know, it's like if you see the mouse by itself and you don't understand that what he did was create a whole new form of transportation and engagement, then you miss the big points. The way I usually like to illustrate what he did, this is from the Mother of All Demos, a video, was this brief section. But I encourage you to go watch this. It's on YouTube. It's all over the place. It's about a little over an hour long, but you'll see things there that, first of all, some of what you take for granted today, which in a sense has been there since he created it, but some of it you're going to see that still doesn't exist. So with any luck, this is a video. Let me know if the sound doesn't come through. It should.
And so this special thing, if I label 13, will switch over. So in his display, he sees my text. So I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting in Menlo Park looking at this text, and he can point to it. but we've carefully reserved for me the right to control and operate on this, so my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I can hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating.
So what I just showed you, you've been obviously, we're doing it right now in a lot of ways. We are sharing an information space. You and I are, you can see me. I can't see you right now, but I know you're there. But more importantly, yeah, one of the things you noticed, they didn't have the term cursor for the mouse pointer. They called it a bug. There's a reason for that. This is literally the first time it was demonstrated to a large audience that here's a mouse, here's a cursor, and then here's collaborative video. And what he was talking about is, I'm going to hand off control to you, and you're going to be able to interact with the same information space that I do. What's really remarkable to me isn't that you could do that. It's the fact that we still don't do it, not in the way he imagined. So he had this idea of collective IQ as a measure of how well people can work together on important challenges, how quickly and intelligently they can anticipate or respond to a situation, leveraging their collective perception, memory, insight, vision, planning, reasoning, foresight, and experience into applicable knowledge. And collective IQ is ultimately a measure of effectiveness. And it's the thing we didn't get in the computer revolution. It's the big missing hole of the system. And there's a real good reason for that. And I'll try to touch on it before we get done with this. But his idea of collective IQ included this concept that he referred to as bootstrapping. So the state of our technology enables us to manipulate information in a much more powerful way, but that ability to manipulate information allows us to create even better technologies. The way to think about this image is it's actually a spiral coming out of the screen. So it's what they call a virtuous cycle. And that's the foundation of what he tried to build, and actually, I think, succeeded in many ways. This was demonstrated, I think, in a powerful way at Xerox PARC, which I'll talk to in a bit. Brett Victor said Englebart's vision from the beginning was collaborative. His vision was people working together in a shared intellectual space. And I really want you to understand that, how important that is. His entire system was designed around that intent. And Alan Kay, who's known as the father of the personal computer for a very good reason, and I'll touch on that, was actually spent a lot of time with Doug in his lab, and saw and understand the importance of that collaborative capability of what that would really mean to people. This is my favorite quote of Alan's: "Man is much more than a tool builder; he's an inventor of universes." And I love that concept. We're not just, you're not just using a mouse to manipulate information. You're using it to create new worlds. And we're just at the start of this. Alan used a kind of as a reference point the idea of reading and writing. It's not that writing in the press made possible a very different kind of travel through time and space, but it was a new manner of traveling through ideas. And that's really what we're after, is this ability to travel through new idea spaces with other people. This picture is really remarkable. Alan had met with Seymour Papert. Seymour was had developed a language called Logo and was working with children to teach them how to program, how to think, and how to create. And after Alan had seen that, previously he had seen the first LCD displays at University of Illinois, and he knew, he was very aware of what became Moore's law, where we'd be seeing a doubling of compute power for the same price every 18 months or so. And so something gelled in his head, and he realized, oh, someday we're going to have a computer that you can hold in your hands. It'll weigh about 2 pounds, and it's going to allow us to explore this information space. This picture is really much more powerful, a lot more going on than you think, because these two children, even though they're kind of looking away from each other, if you look at the screens, they're doing the same thing. They're playing Space War together. And then in 1972, Alan wrote a paper called A Personal Computer for Children of All Ages, where he describes what's really going on was these two children are playing a game together, and then they switch over and are programming the game together. In other words, the original vision of what we think of personal computing, which was this image and the paper that was subsequently written, it was collaborative from the very start. The very first page of that paper describes a collaborative experience between these two children. And as I said, it was based upon Doug's idea of collaboration, but we lost it. It was literally the transition, because Doug's team went from working with Doug and went to Xerox PARC. And oddly enough, the vision that Alan had created for the personal computer was also the thing that killed collaboration. This is an image of what, this is actually a cardboard model of what Alan had in mind. But if you look at this, you can sort of say, oh, that's kind of looks like an iPad. And not surprising, because the iPad actually was based upon this idea space. As you're probably aware, Alan led the team at Xerox PARC to create the first, what we'd consider modern personal computer, which was the Alto. But what you're probably not aware of is they didn't just invent that hardware. They invented the entire language of interaction that we take for granted today. And the way they did that was they built enough of a system for them to build the rest of the system within the system. So as a good example, Alan had the idea in the shower one day that they had this small computer monitor, and had about 1 million pixels, but they couldn't see everything at the same time because they were tiling it. He realized, oh, if you did overlapping windows, you can see everything at the same time. So he invented overlapping windows to solve a problem that they were facing on a regular basis. Dan Ingalls, his partner and the guy who actually implemented Smalltalk, had a similar problem in that he wanted to have an ability to get little information boxes to make selections. And so he actually invented pop-up menus, and he built it in the system. But more important was he did it while the system was running. It was a live system, and it could actually be modified as it was being used. You didn't have to stop, and change something and then restart it and see how that change occurred. And the way to think about it is an artist, and a good programmer is certainly an artist. If an artist did a stroke on a canvas and had to wait, a minute or so to see how the results of that stroke, he'd be at a huge disadvantage. It's very difficult to do art that way. And it's true in programming. If you had to do a stroke and you had to wait a few minutes while you recompiled or whatever to see the results, you have the same problem. You can't see what's going on. Now, this is from 1978, and it's a video. And the reason why I show it to you is only because if I put you down in front of this machine in 1978 and and you saw it, you'd immediately know how to use it because you've been using it. Here.
Is used to select information. A window is selected by moving the cursor inside of it and pressing the first mouse button. A selected window displays above other windows, much like placing a piece of paper on top of a stack on a desk. Information in the window can be selected using this first mouse button. The selected information can be changed. Here, selected text is displayed as white characters on a black background. The selected text is replaced by typing on the keyboard.
This is actually the same system that Steve Jobs saw when he visited Xerox PARC. Dan Ingalls, who I mentioned earlier, was the person who gave him the demo. And Steve actually complained about the fact that when the text was scrolling at a line at a time, which is how a lot of programmers like to have it. And he said, that's wrong. You have to fix that. And it's one of those things Steve always has to criticize. And Dan said, just wait a second. And he opened up a browser, and the things you saw underneath were browsers, were code browsers. And he made one change. He actually removed a line, and all of a sudden it was smooth. And it's sort of one of those things. Steve saw this transformation. Actually, I'm going to put it in his words.
And they showed me really three things. But I was so blinded by the first one that I didn't even really see the other two. One of the things they showed me was object-oriented programming. They showed me that, but I didn't even see that. The other one they showed me was really a networked computer system. They had over 100 Alto computers, all networked, using email, et cetera, et cetera. I didn't even see that. I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I'd ever seen in my life. Now, remember, it was very flawed. What we saw was incomplete. They'd done a bunch of things wrong, but we didn't know that at the time. It's still, though, they had the germ of the idea was there, and they'd done it very well. And within, 10 minutes, it was obvious to me that all computers would work like this.
And it's really interesting. Alan actually said they showed him 10 things. They didn't show him 3. But the idea was he actually saw something happen in front of him, which is this object-oriented live programming that was invisible to him. It went from not working to working in a few seconds, and he didn't see that. And that's really typical. You create these technologies and they're rich and powerful, but in a way they're invisible. And I think that's really a key idea here, is that technologies done right are invisible. You shouldn't see them. They should just work. And this is why, in a sense, it was done so much better than he actually thought, that it was an invisible experience, and which amplified the power he saw. But this is where that breaks down. So January 9th, 2007, Steve Jobs introduced the iPhone. And the iPhone obviously was hugely consequential. It changed. I suspect every one of you probably has some kind of smartphone in your pocket. By the way, pull them out. We're going to try something a little later with that. But what you're looking at here is the iPhone, but it's really important to understand that the iPhone and phones in general is not the same as what Alan envisioned with the Dynabook. In particular, the iPhone's a consumer device. It's it's basically impossible to do any kind of complex creativity. You might have GarageBand, or you might be able to take videos, but you can't use it to think with. Where the idea of the Dynabook and the original vision of the PC indeed was to enable you to create. As I said before, we're inventors of universes, and that's a necessary part of what I think it means to be human in the future. And this is where the grand divide starts occurring. So instead of being creators of the future, we're rapidly becoming consumers, Apple still doesn't really allow programming applications on iPhones. And they're claiming it's security and user experience, but it's sort of scary to me that we're now transitioning to next generation devices that are going to absorb everything. They're going to absorb the phones, they're going to absorb the PCs, they're going to absorb the movie theaters, which is obviously augmented reality, which is, in fact, I think Apple's announcing right now, perhaps the new devices that they've been working on. So AR, I believe, shouldn't be just another phone. Really looking at a device that is going to, as Tim Cook even says, it's going to permeate your life. And if it becomes a consumer device and serve as a great user experience, I think that's a significant danger. So we started this project Croquet many years ago, 20 years ago, with the idea of trying to address that. Steps toward the augmented conversation, and I'm going to define that a bit. But this was the team. You see me, a much younger version of me to the left. Alan Kay, who we've talked about, the father of the personal computer. David Reed is important. David was the architect of the UDP protocol, but was also the co-creator of TCP/IP. Alan calls him the slash in TCP/IP because he figured out that that TCP should be deployed on top of IP. He's also known for Reed's law and the idea of the end-to-end argument, which is the basis of how the internet works. And then Andreas Raab was this Uber hacker who was also my best friend. And the four of us created a system that we think addresses some of the challenges that we face. And I'm going to demonstrate some of this as we go along. And hopefully some of you had a chance to play with it, but certainly I'm going to explore some of that. Let's see, we've got, I think we've got time. So this is sort of a little bit of my story in how I got to that. I've been very interested in, the nature of computing and collaboration, but also extending human engagement via computer. So this first demonstration I did in 1983. And what it is, that's me, much younger. And that I'm using a device called a data glove that maps my hand and position. And I'm controlling a robot arm. And so I'm able to pick things up. I actually built my first head mount for this project so I could do eye-hand coordination at a distance. But what you see there is this idea of how do I project myself into another space, another world, which is exactly the way you should be thinking about AR, because that's what you're going to be doing. This is a game I wrote in 1987. It is the first real-time 3D adventure shooter. There were other 3D games before that. Flight Simulator is probably the most notable, but this is probably the most ambitious game at that time. And you can see it's truly a full 3D environment. That was right there, the most complex 3D object in the world, that little that forklift there. And again, this is 1987. I suspect most of you weren't born. I'm gonna jump forward a little bit. This came out of that work. What happened was Jim Cameron, who was making the movie The Abyss, saw the game and asked me to work on creating a simulation of the set they were building. And so I did that, and I decided, well, there's a real need to be able to create tools for creating 3D worlds. Remember, this is 1990 about. That led to, in fact, I met Alan because of this project. He was a senior fellow at Apple at the time, and so we started discussing what the next steps are in compute and user interface, and the discussion was completely around 3D and collaboration. In other words, what we think of as where AR and VR are going was the centerpiece of what we thought would be the next gen. And so I created the very first collaborative 3D space that I'm aware of, called ICE. This was never shipped. This was a sort of a demonstration application. But everything you see here was collaborative. As I do this, this is, by the way, pre-internet. This is using a local area network to communicate between the machines. And it was all obviously object-based. I can drag and drop a smart object into the scene, and it would generate that simulation. I'm going to jump forward a little bit. This is portals. By the way, I invented portals, oddly enough. But everything you see is sort of this recursion. So I have a space inside of a space. And I'm going to just jump forward a little bit. Okay. This was the first croquet project.
So I'll come in, block, turn into fish. Okay, so what
I'm going to just talk a little bit about, Alan and I decided to get this to go, and everything you see here is in fact totally collaborative. Alan and I are doing a demo to a crowd like you all. And so what you're going to see, this was 2003, I think, was kind of the state of the art at that time, which is sort of weird because I think you'll see stuff that's pretty surprising even today. But so there's two of us. We're both got turned into fish when we went into this space.
do here, since there's not enough fish, I'm going to create my own. So I need to grab a little paint package. And what I'm going to do is literally draw a little fish. Like so. Give it a little bit of an eye and a little bit of color there. And then paint that. And then what's going to happen here, by the way, is the work of, originally the work of Takeo Igarashi, who's now a professor at the University of Tokyo, that's done for his master's thesis, I think, and it's pretty darn cool. Go ahead. What I just did, this is the fastest and easiest 3D design tool you've ever saw in your life. Now Alan's going to make something similar. He's going to add a little seaweed to it. Yeah, so I should come over here, and I'll do the same kind of thing. I'll go get a drawing tool here, and I'll do a much harder problem for this program, which is, what do we call these things? Seaweed? Seaweed. So you can imagine now the system is going to, basically what it has to do is it has to take these planar things that I'm painting and figure out the major and minor axes all over the thing, regardless of what it is, and then use those as a way of spinning out the tiling for the thing. So this is, we'll have to think just a little bit here on this one. I couldn't actually believe that this would work. So of course I never even tried to do it. Wasn't it your kid? Yeah. Dave has a kid, so here it is. And it's coming over here. Thing to notice also, everything we make is automatically copied over. So I've got, I'll grab this and move it around a little bit. Actually, it's not really copied, it's actually recreated. Right. Because this is the replication architecture. So what we've done, it's a shared, I said earlier, this is a collaborative environment. It's a broadband conference call. All of these things are scriptable just the way I showed you. I'm not going to do that right now. But basically, it's all scriptable. And while you're in the routine.
So that was, like I said, 2003. What's really great is the technological infrastructure we have today is far more robust. The first version of Croquet was a bit tricky to use. It was perfectly replicated like this, but you know, this was kind of the first iteration, and we're now on the fourth, which is by far more powerful and much easier to engage with. I'm going to talk a little bit now more about getting back into the augmented conversation I've described, and I haven't really defined it. And the best way to define this idea of an augmented conversation, as I was saying, is sort of the difference between consumer systems and the creative systems, I believe, is this ability for you and I to converse and engage with using the computer. So this is exactly it. Discussion within a group of users, extraordinarily enhanced for the kinds of tools and capabilities that are only available with a computer, right out of Doug Engelbart's playbook. Computer AI is a full participant in the conversation, allows us to jointly discuss and explore complex systems, data sets, simulations. It has to be fully natural, just like I'm talking to you right now. There has to be a guarantee of shared truth. And what I mean by that is the simulation I see is exactly the same as what you see. You might be looking at it from a different perspective, but it's still got to be the same thing. Anything I do to affect the shared simulation must be accurately shared. In other words, you should see me do something as I do it. If that's not true, you won't trust it as a communication channel, which means it fails. I mean, if you don't trust that what you're seeing is what I'm saying, or what you're seeing is what I'm doing, and what you're hearing is what I'm saying, then the channel is, it won't work. So we're in this really interesting point in time where virtual objects are going to populate our world, and they're going to be as responsive and alive as physical objects. In fact, I like to say that there's no, we're talking about augmented reality, virtual reality, and physical reality. In the very near term, you're going to be talking about reality, and there's not going to be any distinction between digital and physical. And again, what you see is exactly what I see. I see exactly what you do as you do it. So augmented reality sort of extends the nature and power of this human narrative. And I know that you're defined more by how you communicate than anything else. And so if that's the case, and we're about to amplify the ability to communicate, expand the scope and the bandwidth of how we engage with each other, I think that the very foundation of what means to be human is about to change. And this is a big deal. I sort of think that humans before reading and writing were a very different species in a sense, because this ability to read and write completely transformed our ability to engage with the world. And as Alan mentioned that earlier, where all of a sudden this idea of history became powerful. This idea of kind of making note of technologies so that you could recreate those technologies down the ages became important. The ability to create idea spaces that could then be traversed by other people, that's such a powerful capability, and we take it for granted. Like I said, anything like this becomes invisible quickly, and you learned how to read and write very early, and so you don't see it as a thing. It's like, this was attributed to Marshall McLuhan, but he didn't really say it, which is, I don't know who discovered water, but it wasn't a fish. And that's where you're at. You're living in this ocean. You don't see the ocean, but that ocean defines you. And the new ocean is about to be upon us, and it's going to be even more transformative. So we're in this really interesting point in time where we have to decide what we're going to become. As I mentioned, we're sort of looking at this crossroads between the consumer environment, the consumer world, and the creation world. Now they overlap. There has to be creators, but when you think about it, the act of creation in this next generation is the same as the ability to write in the past. You have to know how to write to be really able to understand what you read, and that's the challenge. Is are we going to create a society of illiterates, which is a dangerous thing, or are we going to ensure that people are powerful? This is a slide about how croquet works, but I think probably better just kind of give you a quick demo. I think we have time for that. I think some of you may have seen a version of this earlier, but this is Croquet Greenlight, which is built on top of the Croquet platform. And everything here is collaborative. So I can draw here on this whiteboard, and you see that happen over in the other one. And actually, this is kind of where we can have a little bit of fun. Hopefully we don't break anything. But if you have your smartphones, you should be able to scan that QR code with it. just pull your phone out with the camera and point it at that. And what should happen is you should see a link on your phone, and just click that link. And you can see as soon as you do that, you're able to draw on that whiteboard, and you'll see a little latency here between me and you, only because we're doing the video compression. But you get the idea pretty quickly that this is live. We've got 30 people in here already. And there's something magical about you engaging with all these other users in this way. You know, it's like, this is, we're talking about communicating ideas, and you're doing that in just the way I described. Let's do a different one. This is a simulation. And what I'm going to do here, I want you to put this onto your phone, and what's going to happen is it's going to look crazy. But the main thing to note, go ahead and scan that QR code. You should be seeing, yeah, see, it's like exactly, you start tapping the screen and you launch these objects into the scene. You should see exactly the same thing. Like I said, there's more latency on my side only because of the video compression that's occurring. So you won't, yeah, you're going to see a little bit delayed, but if you look at where all the little cubes and things are, they're exactly the same location. And that simulation is running vid identical on all our systems with virtually no, almost no delay. You should be seeing latencies, since a lot of you up in the Northwest, which is where this reflector happens to be. You're looking at latencies on the order of 20, 30 milliseconds. Here's a different example. I'm not going to, actually, I can, no, I'm not going to do this one. I'm going to spin it around a little bit to show you what it would be like. But this is a very different kind of example of an application. And again, it'd be collaborative. The only reason I'm not showing it is I have no idea what would happen if all of you were on it, but it probably wouldn't do very well. But if it's only a few people, it works it works great. Another thing that we've done is a co-browser. So this is University of Washington. Oops, that's probably good enough. You'll probably know what I mean. And then reality. And so we're sharing. And what you saw was a very different approach from what you're used to with traditional systems. Usually you have this client server model where you interact with a local view, message gets sent up the server owns truth, and the server says back to the view. This is all that stuff that changed. Croquet doesn't work that way. You're actually running a shared virtual computer, a bit identical replicated computer. This is David Reed's thesis. And what happens is you interact with the local view, a message gets sent up to a thing called a reflector. Reflector has no application state. All it does is takes that message, puts a timestamp on it, redistributes it to the virtual machines that are shared, and then the view is alerted that something has changed. So when you saw that physics engine running, if you put that on your PC and your phone at the same time, you'd see you could almost use them as stereo pairs. They're that close. And this is, the nice thing about this is, first of all the code's on the client side. The other side is it's super, super fast. The limit is only the time to the reflector and back, which means that if you are able to place a reflector close to you, that means your latency is going to be extremely low. And why does that matter? When you're using AR in the future, you're going to want to be able to engage with other people and with these virtual systems, and latency is everything. So I want to pick up a virtual object and engage with it and throw it or do whatever, and it has to act as real and lively as an actual physical object. That means that the time delay between my decision to engage with it to when it impacts my consciousness has to be extraordinarily low. And we see 5G as a way to achieve just that. And so we're very interested in taking these reflectors and putting them on 5G networks in the future. I already did this. What else? Here's some other things that are necessary for this augmented conversation. Security, it can't just do encryption. Tracking a user's body is so valuable to people who want to learn about you. And so the kind of information that is being shared, for example, with something like the Oculus, is probably way more than you want them to know. It's sort of not just where your body is, your body shape, but what are you looking at? And how are you reacting to what you're looking at? Your body has a visceral reaction to that, which means then if somebody can watch that, they can actually do a feedback loop and start modifying and controlling your attention, because they are creating a model of you and how you think and how you respond. Another one, I mentioned this idea of an invisible interface earlier. When you use a mouse, you probably don't think of it very often because, again, it's an invisible thing to you. But interesting thing about a mouse is if you move it a few inches, if you move it fast a few inches, it'll move feet. If you move it slowly a few inches, you have such fine-grained control that you're able to put a cursor between two letters. And think about that, is that if somebody's watching you from the outside, they don't really see you doing all those actions. It's very subtle. It's basically next thing to being invisible. And that's what we have to do for AR. A lot of people put their hands up in the air and you're trying to like conduct an orchestra. This is exactly the wrong way to build interfaces. If that robot arm control I showed you earlier is a perfect example, and it was really what taught me the problem. So I had my hand up in the air. I'm trying to interact with it, control this robot hand. And so I had to stiffen up my arm with this agonist-antagonist system to control it. You probably didn't notice is I'm literally sweating under my arm. It was hard to do that. And unfortunately, that's what people are building today. And this goes back to what I was talking about earlier with the way Smalltalk was developed, which was they used the system to build the system itself. And so when we think about building the next generation of AR interfaces, my contention is you have to build the next generation AR systems within AR, because it's sort of like you try to build a ship in a bottle, and it's a beautiful ship, but then you launch it, it's going to sink because all your assumptions about the ocean are probably wrong because you never did that. Instead, what you want to do is launch a raft and build up a battleship from that raft, because everything you do is going to be dictated by the environment and the requirements of that environment. And so you're going to start adding functions and features that allow you to keep that raft afloat, or even better, improve its capability to live with that environment, which is the whole point. End user programming is a key element. The original idea of Smalltalk was that it would be that. Part of the problem was it was so successful as a systems programming language that it kind of took a little bit of a right turn. But HyperCard was a really great example. HyperTalk was the language for programming HyperCard, very English-like. Objects within HyperCard were concrete. You could touch them. You could then tell them what you wanted them to do when certain things happen. And you have to start thinking about what's a HyperCard-like thing for AR, where we can breathe life into those objects that we're part of. And then really key is AI is in service to the human. I think this is, people don't understand quite this way. Usually we're looking at AIs as tracking what you do and maybe assisting, but really they don't work for you. They work for some big company. But the one way to think about it is they should be there to certainly service your requests, amplify your intentions, act as a user agent when you're not able to engage. What would David do? But a really key one is acting as a prophylactic. In other words, defending you against these external AIs, so that first of all, you're aware that you're being watched or attempting to be controlled. So, and this is a thing that I think really has to be thought of, is we have to have a closed AI, one that's owned and controlled only by you and doesn't only has indirect interactions with these external systems, but it's really a direct extension of your brain in a fully symbiotic system, as I was saying. And it is the mediator between you and the other participants in that augmented conversation. So going back to Alan, I took this picture, by the way. I think it's my favorite picture of him. He said this wonderful thing: the computer is an instrument whose music is ideas, which is right. You know, it's like the piano. You know, where's the music live? It's not in the piano. Right? It's in you. Then you're able to express those ideas in the same way with a computer. And augmented conversation to me is jazz. You and I are engaging in this wonderful, complex space, and we're creating together, exploring together in the same way that a great jazz group explores new ideas. You still bring some older ideas to it. You explore the same things sometimes, but sometimes magical things happen as part of that brainstorm. Finally, Albert Einstein is reputed to have said this: we cannot solve our problems with the same thinking we used when we created them. And unfortunately, that's what we're seeing. You know, we don't understand complexity. We don't understand how to even describe the problems we face yet. And the only way we're going to address them is, as Doug said, collaboratively. And that's it. I hope that was useful. I'm going to stop sharing now, and I'm happy to answer questions or amplify what I said. Anyway, go for it.
Thank you, David. That was wonderful and very inspiring. We have a bunch of questions. Rishabh, do you want to go for it?
Yeah. So I kind of had a question about latency. So is latency, like you said, latency is everything. Is that the only limiting factor right now? At what latency would you say like a virtual object and a physical object feel and act the same?
Yeah, latency is very, very important, much more than bandwidth. So humans actually notice latency when you get up into the 50, 60, 70 millisecond range. If you can keep it down to 20 milliseconds or less, then you get the sense of instantaneous action. So when you're thinking about an AR application, and I pick up a virtual object, I'm picking this thing up, and imagine that's virtual, and it tracks my hand as well as this physical does, at least for my perception. That's right. That's the way it should be. And I see you do the same thing. You pick up a virtual object and you're interacting with it. It's really, really important that that latency be extremely low for a number of reasons. One is I feel like it's real, but the other thing is it's that paintbrush analogy again. So if I painted a stroke in front of me and that stroke was delayed by, say, 300 milliseconds, what would happen is my ability to feel I'm in control, my ability to see what's going on would be really disastrously limited. Yet we need to be able to do that with other people. And so latency in that regard, for me, when I'm doing this and I can see it happening as if it's real, and you'd see the same thing, is really an essential aspect of a truly engaging system. So yeah, I think latency is a huge deal, and it's a core component of what I think of really great UI and UX it is. So it's one of those things that latency way more important than anything, especially when you're collaborating. So pick up, if you and I are going to pick up two ends of a beam, another good example. And if you've got a high latency, then you're not going to do something in quite the same way. I'm going to see, oh, he's dropping it over there or whatever. It's just I think you really need that super high speed, high speed effect, that feedback, and to make it truly feel live. Any other questions?
Just as a follow-up, I was just wondering how close are we to getting to that point, or are we there yet?
In some ways, pretty good. It depends on a lot of things. So as an example, I have fiber. I might have it here, but I certainly have it at my house. And we have the reflector. My home is in North Carolina. The reflector is actually, and that one is in Raleigh. It is in Richmond, Virginia, and I get 15 millisecond latencies with that. What you're going to see with 5G when it's done right is, you're connecting via a very high speed radio from your 5G phone to the cell tower, which then forwards that message to a kind of a local, a semi-local data center. The round trip there may be as low as 10 milliseconds. So that means if you and I are together using this AR system, we could almost play music together. It's that good. So yeah, we're getting very, very close to being able to provide this kind of latencies I think you really need for that really deep engagement.
Rajan, do you want to go next?
Yeah. So I had a question about, you talked about how hand gestures are still not natural. I'm curious that if hand gestures, because they can make your hands tired, what are some possible directions of investigation when somebody wants to interact with AR content? Something that is natural, is not tiring.
Yeah, I have very strong opinions about that. First of all, I don't think that hand gestures are bad. They're just not you don't want to be using them all the time. And in fact, you can still do hand gestures with your hands to your side. And I go back to the mouse as an example where you're resting your hand on the mouse and it's nowhere near the screen, but you're projecting that cursor, your brain, we learned how to use tools as a species a long, long time ago. And so we're extending our body via this mouse onto this controlling of this little pointer. And that's kind of the way to think about gesturing is you might take something like there's a device called a tap, which is sort of allows you to sort of do chording. Doug Engelbart had this idea of a chording keyboard. Watch that video of the Motherwell demos, you'll see that in action. But so you can imagine a way of it's like you play piano or use your keyboard, but your arm could be to your side and doing that. But there's other modalities that all of a sudden become very useful. For example, voice. I mean, you're wearing a computer, you don't have a keyboard. Voice is going to be very central to that engagement. You're going to be able to tell the system to do something, or you're going to be able to kind of manipulate. So you think about it, your eyes, which are looking and acting as sort of your mouse cursor, and your voice, which is able to add the verbs. So your eyes are nouns and your voice is the verbs, are able to do an incredible amount. And so we really need to extend the whole body interaction into that domain. And so the hands are an important part. But like I said, if I see you doing this, kind of trying to conduct it, that's fine. It doesn't mean it's bad, but it does mean you're not going to be doing that for an hour. You're going to get tired. I know that. I've done that. And so you need to have these other modalities that are a lot more comfortable, but also more powerful. As I talk about this invisible interface, and like I said, is if I see you doing it, you're failing. What you really want, the ultimate interface is you think something and it happens. And I'm not a real fan of like putting, transistors in my brain, but you want that kind of engagement where you sort of, at least that feels that way. I look at something and I think something about it, and that's what happens, is sort of the ideal. And I think we can get there, and it may well be we have, you know, kind of brain sensors and feedback mechanisms at some point. I think we can get pretty far without it, but that's the goal. Think of it when you're designing an interface, you know, think about it as what's the least amount of work I can do to make this thing happen. So that's really what I mean.
Thanks.
Sam, do you want to go next?
So why hasn't like the vision of like the creative interaction with the computer, like the original tablet rather than the consumer phone, like why isn't that like more taken root and had more momentum in interaction with technology?
That's a terrifically good question. Part of it, let's just take the phone. Apple was extraordinarily successful providing this as a consumer device, and there's a, you know, it was financially rewarding. They controlled what you saw, how you saw it, and they got paid for that. And by the way, there's some truth to the concern that, you know, if you have a programming environment, then there's a security risk, but that's, you know, power always has security risks. I sort of see it in a sense, it was a choice made by both Apple, I'm not picking on Apple, but all the technology providers and the consumers. It's a very easy path to go down. What I object to isn't that they did that. What I object to is that they didn't give you the option of providing more powerful concepts and more powerful engagement that allowed you to continue to create inside those environments. And I think part of it too is the very nature of collaborating with other people is a creation experience, and that's just not there yet. You know, that got lost. You can make a phone call to somebody, but that's not the same as, you know, co-creation in a shared environment. I also have one other point I should mention is one of the big problems I see, and I might be wrong about this, but I think that all these device manufacturers are going to create, they like the idea of a walled garden where this is an environment where you get to be successful and play. And so what that means in a sense is they don't want people with other systems to play with you. The way to think about it is, you know, if you have an iPhone, assume you had an iPhone and you could only call other iPhones. So if your friend has an Android, they're out of luck. That's why I see this going. And it's like, we used to call a thing called POTS, plain old telephone service. Today, you can call every phone on the planet basically from your phone. You could dial random numbers, probably somebody on the other side of that. And so imagine that you couldn't. Imagine that, oh yeah, you've got the new iDevice or the new Android device, and you can call anybody else you want as long as they have an iDevice. It's such a weird thing. It's like we're talking about the very nature of communication and collaboration, and if it's limited that way, it's clearly broken. So I think that that's a good part of it. The idea when people get together, they're creative by nature, and that would have created a lot of pressure for the inclusion of the tools that allow us to think together.
Gotcha. Before the iPhone was created, then was there sort of more of a creative bent towards like technology interaction, or like,
yeah,
if it wasn't, what was preventing it?
So Apple used to have this great phrase describing the Mac, because they used to be just the Macintosh and obviously Apple II before that. They referred to the Macintosh as bicycles for the mind. You know, the interesting thing about the bicycle is it takes us as sort of a pretty inefficient being and turns us into the most efficient animal on the planet. And a bicycles for the mind was such a powerful idea where we're amplifying your abilities to think and explore with these devices. They never refer to that anymore, right? That was that got lost in the mists of time. But that was, I think they embraced that idea at the beginning and saw that as important. And at some point, as I said, the niche transformed into something that was, the consumer side eclipsed the creation side. And by the way, going back to even Alan's paper, where he talks about these two children, they start out playing a game together. They're playing Space War. So that's sort of the consumer side. They were having fun. The big difference was they were able to say, oh, we didn't like that part of the game. Let's reach into the code of that game and modify it to make it more fair or make it more interesting. And they were able to do that. And obviously you would never consider doing such a thing on an iPhone or even a tablet, which is a shame.
Gotcha. I could have more questions, but I want to give other people a chance too.
Sure. And feel free to email me. I'm david@croquet.io.
Well, people are all thinking. David, so what, given like all of your experience in the field from the last many years, what do you think the next kind of big thing to work on in the, like, I don't know, the next 10 years or so? What is like the big open problem that the young minds of today should focus on?
Yeah.
In your opinion.
I think that, obviously you can tell my passion is this nature of collaboration, but we don't really know what that means. We can talk about it a bit, and it's like, oh, what happens when you and I share this thing, these ideas, these spaces? We really don't know where that's going to lead. I suspect that part of the problem was that these kind of technologies were not very good. They were hard to use. In my mind, given where these came from, I sort of see this Croquet and Croquet-like systems are kind of a missing protocol of the internet. So imagine, go back in time and somebody says, hey, look, I've got this TCP/IP thing where I can connect to all these different computers and grab data from them. And I can, I can create maybe I can create web pages with HTTP and World Wide Web. It's literally a new frontier when you're all of a sudden able to collaborate and share ideas as easily as we can here, which means that the Facebook of collaboration, the Google of collaboration hasn't been created yet. We don't know what it looks like. We don't know what it's like. You think about it this way. When Google was started, people didn't think it was that important. They said, oh yeah, you can search the web. And I saw it, actually, the way I found Google was I kind of came up with this idea of what they call PageRank, where you're using how many people link to you as the value. And I thought, well, I hope no one's done this. And of course I do a search using the very bad tools we had at that point, and I find Google, and I said, shit. First of all, they got ahead of me, but oh my God, it works great. And I think that's where we're at. We're now seeing these new technologies, and it's a mix. We're seeing AI, we're seeing AR, we're seeing collaboration. These things are going to create fundamentally new kinds of capabilities, new kinds of businesses that we haven't imagined yet. And so what I would do right now is I'd be building systems that incorporate all three of those things, and others. I mean, there's those are the three high points in a sense. AI, AR, and collaboration, I think, really are kind of a wonderful mix of capabilities. But that the Facebook of that domain hasn't been invented. And it would be really good if it wasn't Facebook that did invent it. I think there's an opportunity for disruption of our industry and it's likely somebody, in this audience has got a high probability of coming up with something that has that impact. You really want to have the freedom in your brain to explore these ideas and build something crazy, because that's what we need. Actually, we need to have these new things that people hadn't thought of yet, and this is the time. We're at the beginning of this next generation of capabilities. So this is the best time that in your lifetime to be able to explore that.
Yeah. Hi, David. I appreciate your passion for collaboration. I think that has really shown throughout your speech. So building off Sam's and the professor's question, I'm a little confused by this distinction between the creation and consumer side. I was just wondering if you think that the AR has to like cross the chasm into the consumer market, and if so, when will this happen, or like what is stopping it?
Yeah, there's a foundational difference to me. I mean, I sort of think of it, I'm a programmer, and when you see things like HyperCard, which is sort of an end user programming language that was developed at Apple, you sort of see this idea, I can create my own spaces and share those spaces. I can create my own applications and share those. And there's a marked difference. I mean, you look at your iPhone and you can go get an app, and the app actually may allow you to have some level of creativity. I might have maybe a little video editing capability, but you really can't create new apps there. You can't express kind of new idea spaces in here that you can then make available. And so I think that's the big distinction of that device. But one of the things that's really important is that all of you have PCs and you have phones. The PC is still pretty much the place you create, and the phone is still pretty much the place you consume. But what happens when you have a device that eats it all? And that's what's going to happen. You're going to have an AR device is going to replace every screen you've ever seen. It's going to replace movie theaters, because these devices are going to get good enough that you can have a 100-foot movie theater in 3D in front of you anytime you want. The idea of having a laptop is ludicrous in a world like that. You're not going to have that. You're going to have this ability to project information and ideas in front of you anytime you like, which means then that part of the PC infrastructure that we use today, which is to create, is going to go away. It's got to be supported only by the head mount. And the question is it going to? Are we going to be allowed to by the people who are providing those capabilities, those systems? And that's a simple question, I think, because that's a distinction to me, is that I want to be able to replace my PC with these devices, but I want to have the same power, the same expressive capability. I don't want to just read what other people write. I want to be able to write it myself. And writing in this case means using some kind of computer system that turns my ideas into a working system that I can share.
I guess my follow-up question is like, I feel like there is a lot of like, there is talk of like maybe Apple and like other companies entering this consumer space. I just don't know if entering this consumer space, especially given what you just said, maybe they would still provide a very consumer side product in which the creation and collaboration aspect is like diminished. I was wondering your thoughts on that, and whether maybe they see this as the way that they can market the product without making it like overly complicated to the lay person who might not be interested in like the creation or collaboration aspect to it.
Well, they follow the money, and clearly the money is in entertaining, entertaining the user. So they're very focused on great user experience, which is wonderful in a lot of ways, but it doesn't necessarily mean that you're empowering the user. That's not necessary. What's necessary is that the user be satisfied and happy with whatever you do, because that's where, like I said, that's where the money is. So it may not be a priority for them. It might be, that would be good. But my guess is it's certainly, if you looked at the hierarchy of their priorities, it's probably not the top one. And that's where the danger perhaps exists. That the real danger is people are going to be satisfied with what they're given, and there becomes less and less a need for you to think for yourself. And we already see what happens when that occurs in society, is when you abrogate the responsibility to think, things don't go very well. Thomas Jefferson realized that it was essential that the population be educated. The primary reason for that was that the education, the population was going to be the ones who elected the leadership of the country. And so the value we're putting into this leadership's hands, the future of the country. And if you're electing people as an uneducated group, you may not make very good choices. And so that, hence the danger, why public education is so crucial. And we're not doing a very good job of that lately, I think. And when we start looking at these new devices, we have to think of them as, there's two sides of a good education. It's the reading and the writing. If all we do is say, oh, you can read, but you can't write, you're not going to be truly educated. You're not going to understand the meaning of things if you're unable to express it yourself.
Can I ask a next question?
Thank you.
Just like expanding on the previous question, to what extent, or like what are the means that you imagine that we'll be able to create content in AR? Because I feel like no matter what no matter what you use, like PC or AR, you still need to program something, because like it's so easy to express things mathematically compared to like moving boxes around just in Unity. I mean, even Unity, you need to code a lot.
That's right. I think coding is not going away. So here's you're exactly right, by the way. So here's the challenge. So Scratch was developed, the original version of Scratch, or the predecessor of Scratch, was called eToys, that Alan developed with his team. And then one of his team went over to MIT and they built Scratch. There was a big distinction between the two. With eToys, you could actually there was no ceiling. You could actually switch over at some point to Smalltalk and you could do anything, any kind of programming you needed to. Scratch actually has a ceiling that you can do a certain set of things, but you can't do anything more than that. And that's where the real trick is. I think the nice thing about kids who grew up with Scratch, they did understand the programming concepts. And so maybe when they were introduced to kind of more hardcore kinds of languages, they were able to internalize that better. But yeah, I don't know that programming is necessarily going to go away. It may change. I think you're going to still have to express algorithms in some form. You might be speaking them, but remember, there's a very tight feedback loop, just like you have with your computer screen. You say something, you're going to see something, you're going to run it and see how it simulates, and you say, oh, make this change, make that change. So it definitely is electronic modeling clay. So I don't feel like programming is ever going to quite go away, but I think it's going to get if you have AI assistants helping you with a lot of this, you know what, it's sort of the idea of do what I meant, not what I said. That may become a reality. Of course, that may be a slippery slope too, right? In other words, it's like, oh, well, he really wanted this and you really didn't, but it looks pretty good, so you're letting it go. That's I can't really say I know the answer, but I do think that it's you know, the idea of transforming ideas into algorithms and simulations is what programming really is about. And I don't see that necessarily going away. I do think collaboratively working on that is going to be quite powerful, because it's important to be able to express these ideas, not just to the computer, but to the other participants in a way that's meaningful to them. So I do think that programming languages that are more natural language-like are going to arise, and I think they'll be quite powerful.
Yeah.
So that's my hope anyway.
And then to be able to visualize
Yep.
what you just say. Yeah. Got it. Thank you.
Sure.
Thank you, David. Let's do a collaborative applause. Let's try. Turn on your mics.
It's very funny. Yeah. Thank you very much. This is fun. Thank you all. Bye.